Hi, Algebra 2. Hi, Honors. Wanted to take a look at one of the example problems from the quizzes exercises that we did today on Friday and walk through the process of solving a system of equations with three variables, three equations. So let's work on this one. This one was number 2, and negative 6x minus 4y plus 3z equals 7, and negative 2x plus 5y plus z equals 15, and x minus 5y plus 6z equals negative 19. So I'm going to label these equation 1, equation 2, and equation 3. All right, so our first thing that we need to remember is we're trying to combine two different pairs of equations with the goal of eliminating the same variable both times. So I want to add together two of these equations out of the three so that one of the variables is eliminated. And then I want to go back and pick a different pair of two and add those together so that the same variable is eliminated. So as a for instance, let's take a look here because this definitely jumps out at me. I see a positive 5y and a negative 5y. If I combine these two equations, 2 and 3, I'm going to eliminate the y. Now, I need to pick another pair of equations to combine to eliminate the y again, and I can see that I don't have a multiple here. I could do it. I would multiply the first equation by 5, the second by 4, okay, which might be a little bit more work than I want to do. With the z, this is a little more doable. I have a 1z here, 3 and 6. So if I combine the first two and multiply the middle one by negative 3, and then multiply by negative 6 and combine the second two, that'll go ahead and eliminate my z twice. But I also see I have a positive x here, a negative 2 and negative 6. So I'm going to go ahead and tackle the x first. So let's do this. I'm going to go add 2 plus 2 times equation 3. So negative 2x plus 5y plus z equals 15. And then I'm going to double this second one. Positive 2x minus 10y plus 12z equals negative 38. Positive 2x, negative 2x. That goes to 0. Positive 5, negative 10. I have a negative 5y plus 13z. And then positive 15, negative 38. That's going to give me negative 23. So that's my equation 4. All right, so now I need to go back in and I'm going to combine a different pair of equations from my originals. So I'm going to go with 1 plus 6 times equation 3. Negative 6x minus 4y plus 3z equals 7. And this one I'm going to scale up times 6. So 6x minus 30y plus 36z, and then 19 times 6. Go to your calculator for that one, right? Negative 114. So we add these together. This goes to 0. Negative 34y plus 39z equals negative 107. And that's my equation 5. All right, so now I have equation 4 and equation 5. And I'm going to line these up just so I can see them side by side or one above the other. Give me a chance to see where I need to go with this. So just to recap what we did here, we eliminated the same variable twice. So I came up with a new pair of equations that both had the same variable in them. So I eliminated x twice, and I have just y's and z's, just y's and z's. So let's see what's going on here. So I'm looking at this, 13 and 39. If I multiply that first equation by negative 3, I'll get a negative 39 here. I'll be able to eliminate my z's. So let's do that. So 15y plus 39z, oops, that's a negative 3, So minus 39z, and then 23 times 3, right there. Second one we're going to leave alone. Negative 34y plus 39z equals negative 107. All right, so 34 I'm going to have a negative 19y. Negative 39, positive 39 goes away. And then I have a 107, 69 equals negative 38. So if I divide both sides by negative 19, y equals 2. So remember, my solution to a system of 3 equations, 3 variables is going to be an ordered triple. So I'm going to go ahead and write my parentheses, x, y, z. Here's my y value. Okay, so I know I can go back in and get my z by taking y and substituting into one of the original equations. So negative 5y plus 13z equals negative 23. So let's multiply negative 5 times 2 plus 13z equals negative 23. So negative 10 13z equals negative 13. So now my z is negative 1. All right, so I have a value for y. I have a value for z. What's left? I need to come back to one of my original equations and get a value for x. So let's pick whichever one we think is easiest to work with. And I'm going to go with the last one, equation 3, x minus 5y plus 6z equals negative 19. So x minus 5 times 2 plus 6 times negative 1 equals negative 19. Negative 5 times 2, negative 10, minus 6 equals negative 19. So negative 10 minus 6, that's negative 16. Negative 19, let's add 16 on both sides. And x equals negative 3. So we get negative 3, 2, negative 1 for our solution. So this is the process. And as we said, as we were working through this, it's tedious, right? It's not the kind of problem you're just going to look at and obviously be able to see the answer. It's not the kind of problem that you're going to be done with in 30 seconds, right? You need to allow some time for this. So, when we get to the quiz, it obviously can't be just like a multiple choice, multiple guess kind of situation, but definitely the process in here is going to be something I'm going to be asking you guys about. Right? So those are the things that you want to be able to look at when we get to the quiz on next week.